we have to make some variable here. So let me made it as well, rs is equals to render script and then create, adding the context. Okay, let me also tell you why I am creating this class. Actually, this is a helper class which will be used for converting the image object from image format YUV42088 to bitmap object. Then YUV.RGB method will be using for getting the image of a limited size. Okay, so here we have to create a script YUV to RGB variable, and then the script intrinsic YUV to RGB dot create, and passing we have to pass dot create. Let me remove this. Okay, now dot create, and you have to pass rs and then element dot u8 underscore 4. Okay, so here 2 3 4. Okay, then again rs. Okay, so now you have to take the pixel count also, as this class will also responsible for getting the pixels with 30 fps and 640 into 480 pixels or resolution, you can see that, because this is the default analyzer resolution that will be needed for our machine learning model. Okay, so now the input allocation is being made output allocation, and then the buffer is also ready, YUV buffer. Then we have to make another variable, and it is pixel count. Give the value as -1. I have forgot it to create it at the first side, don't worry about it. And here I have to create a synchronized method called YUV to RGB, and make sure this method is very important. Actually, this method is able to achieve the same FPS as the camera X image analysis use case on a Pixel 3 XL device at the default analyzer resolution, which is 30 fps with 640 into 480 pixels or resolutions. So first of all, within this method we are checking or ensuring that the intermediate output byte buffer is allocated. Okay, so here we are cropping it according to our size, and bits per pixel is then average for the whole image, so it's useful to compute the size of the full buffer, but it should not be used to determine the pixel offsets. Okay, so now the pixel size bits we have to take it here, and it should be YUV 422,888, as we are going to convert it to bitmap. Okay, then storing it within the YUV buffer. Okay, and then you have to allocate directly pixel count into pixel size bits divided by 8. Okay, so this is complete, and afterwards we have to rewind the buffer. No need to clear it since it will be filled, so we just have to write YUV buffer dot rewind. Now for getting the YUV data in the byte array from using NB21 format, we have to use a byte array form. Okay, so we are converting it into that array form. So here we are doing it with this custom function. Don't worry about the error. We have to create this function customly that we are going to do again. Okay, and now we have to also ensure the render scripts input and outputs are allocated. So here we have to check for that using the if condition. If input allocation is initialized, okay, again within this we have to explicitly create an element with type NV21, since that's the pixel format we will going to use within this project. So element type dot builder, pass rs element dot yub, rs dot set yub format, and image format dot nv21, then create it. Afterwards you have to give it to that input allocation, and we have to do check for the same but for output allocation after doing this. So now the input allocation, as we have to complete the input allocation first, then we will be moving ahead for that output allocation. Okay, so create sized rs comma element type dot element, then yub buffer dot array offset, array only. Okay, then size. Okay, so now this if is completed, and we have to do the same for the output allocation also. So we will be just checking for this initialization of the output allocation here, and afterwards we will be giving the value for output allocation as take it from that create from bitmap. Okay, so allocation dot create from bitmap, and then we have to pass rs and output within this. Okay, then we have to convert NB21 format YUB to RGB. That is our motto. So we just have to write something like input allocation dot copy from YUB buffer dot array, and then script YUB to RGB dot set input. We have to set the input allocation, and then finally we have to move for each element of the array. So we are going to use for each, then copy it to that output allocation, pass output within this. Okay, so now this is completed, and now we have to make or create this custom function. So we have created this, and within this function we have to check for the values that are in the readable form for each input and output, and we have to move on y plane has a value for every pixel, and u and b have the half resolution. So we are just getting the image into a matrix form, then we are just splitting the matrix into u and v plane from y plane. So here first of all I'm just checking for the build configuration and debug things here, and if the error occurs, then error assertion failed, then we will be cropping the image and setting the planes. Okay, afterwards we will be moving towards the planes, and for each plane we will be getting that full matrix into two matrix part. Okay, so now the image planes is done. Now the main part starts. So here what we are doing, I'm telling you again, how many values are in read for input and for each output value written. Only the y plane has the value for every pixel. U and v have half resolutions. That is, if y plane is a matrix, then u and v will be the submatrix for the y plane matrix. Okay, so you just have to make output stride and then output offset. So for the index in the output buffer, the next value will be written at, for y it's 0, and for u and v we start at the end of y and interleave them. Okay, so we are just getting from the values of first matrix as first chunk and the second as second chunk. So we are just getting these two matrices u plane and v plane into a one, and we are just interleaving them. Okay, so now we are giving the values for it as 1 and 0 and 2. As for NV21 format, u is in odd number indices, that's why +1, and then we have to, for NV21, v is in even number indices, that's why only pixel count, and again we have to give the else, that's the image contain more than 3 planes, then something strange will going on, so just return at for each index. Okay, afterwards we have to divide the width and height by 2 if it's not the y plane, so we will be doing it here only, and it is like wall plane crop equals to if, and then like plane buffer, and then row stride and pixel stride, finally the pixel stride here. Afterwards we have to divide the width and height by 2 if it's not in the same y plane. So first of all we have to check by using the if condition, plane index equals to 0. If it is 0, then image crop. If it is not, then make the else condition, but write image crop, then the else condition, and this else condition will make another thing rect, and you just have to divide the whole thing by 2, like rect, then image crop dot left divide by 2, then do the same for the top part, bottom part, and the right part. So first of all the left, then the top, again the right, and then finally the bottom in the last. Okay, so now get the new height and width in the plane width variables. So here we have to make 2 more variables, so let me make it here. Okay, so width and height. Now for intermediate buffer used to store the byte for each row, we have to make raw buffer here. So let me create another variable here for raw buffer, and it will be giving you intermediate buffer used to store the bytes for each row. Okay, so byte plane dot row stride. Okay, so now the size of each row in bytes will be stored in variable called row length. So first of all the if condition, if pixel stride is 1 and output stride is 1, then the plane width. Otherwise in the else part you have to make sure that taking into the account that the stride may include data from the pixels other than this particular plane and row, and that could be between pixel and not every pixel. So we have to divide it between pixel stride, and pixel stride will contain pixel 1 other data, pixel 2 other data, and pixel n, and so on and so forth. We need to get n-1 into pixel stride bytes per row plus 1 bytes for the last pixel. So here we have done with this. Now we have to move to buffer position to the beginning of the row. That's why we are making this loop, and then the plain buffer dot position, and here we have to write row plus plain crop dot top and dot top and multiply by row stride plus plain crop dot left and multiply by pixel stride. Okay, afterwards we have to check for the pixel stride and output stride 1. Then when there is a single stride value for the pixel and the output, we can just copy the entire row in a single step. And what will be it? And this should be within this if condition, like copying the entire row in a single step, like plain buffer dot get and output buffer, output offset and row length. Then output offset will be increased by row length, so we have to add it up within this. So output offset plus equals to row length. Okay, then the else condition, when either the pixel or the output have the stride that should be greater than 1, then we must copy it by pixel. If it is not, then the if condition run. If it is a true, like either pixel or output having a stride greater than 1, then you have to copy it by pixel. So you have to make a loop here. You cannot go in one step. You have to make a loop, and then you have to traverse on this, like output buffer output offset equals to row buffer column into pixel stride, and then output offset plus equals to output stride. Okay, so this class is completed, and this is a helper class. Also one error is there. Let me check what does that error says, but I think there should be no issue with it. Let me check for the error. So here we are having the error as the output offset is a kind of variable, but we have to make it a var variable. Okay, so let me check if there something messy if I convert it within this. So let me again, var cannot be assigned. Okay, so the issue is same. So let me change its type here. So I will just change the type of the variable called output offset. Okay, so before changing the type, let me think twice, because we are merging two technologies here and this class is very crucial. So let me go again, and then finally I'm changing it to var. Okay, so just trying to changing it, like go to its declaration and then make it var. So now you can see that this class is error free, and now I'm just scrolling it down, and if you get messed up at anywhere, then please pause the video and correct your code. There should be no errors within this class. Okay, and everything should be same as I have written, and I'm just scrolling it slower and slower so that can pause the video and correct the code. Okay, so it is done. Now let me add the ML model file that is being converted from H5 model to TF Lite. Okay, now I have converted it using that Jupyter notebook. Now come back within this Android Studio and go to show in files. Right click on that and then click on show in files. Afterwards go to that src folder, then main folder, and here you have to create another folder, and another folder called ML, and you just have to copy that custom model that is trained within the Jupyter notebook and convert it to TF Lite. TF Lite is a format that is useful for machine learning models on Android devices. So I have converted it and finally pasted it within this ML folder. Now you can see that the ML folder is there in the last part. Now let me just click on